All right, we're going to pull back the curtain on a design element you experience every single day, but probably, and I mean probably, never really notice: lighting. It's this hidden science that's constantly shaping how you feel and how you perform in every single room you enter. You know that feeling, right? You walk into a place and it just feels right. Maybe it's comfortable, maybe it's welcoming, or it's perfectly set up for you to focus. You can't quite put your finger on why, but I'll tell you this, it is no accident.
Well, here's the thing. That feeling, it's not magic. It's the result of a really delicate balancing act, a whole series of calculated decisions that a designer has to make. It's a science, and it's a science that is built on very specific trade-offs.
At the heart of all this are three big competing goals. First, you've got visual comfort, just making a space pleasant to be in. Second, there's task performance, making sure you have enough light to actually do what you need to do. And third, energy efficiency, doing all of that without wasting a ton of power. And every single lighting design is this constant negotiation between these three pillars.
Okay, so if you're a designer, where do you even begin? Well, you start with the most basic question of all. How much light do we actually need? This right here is the foundation that everything else gets built on. So, the fancy technical term for how much light is maintained illuminance. You can just think of it as the raw power of the lighting system measured in something called lux. And listen, this isn't just about how bright it is on day one. No. It's the minimum average light that's required on a surface, like your desk, over the entire life of the installation. It's all to make sure you can always see what you're doing. And just look at how dramatically that need changes depending on the space. A simple corridor, yeah, that only needs about 100 lux. But a general office, you got to bump that up 5 times to 500 lux. And for really detailed precision work, you could be looking at 1,000 lux or even more. The task always dictates the power. Okay, so having enough light is one thing, but raw power isn't everything. A room can be super bright and still feel just awful. And that's what brings us to the art of comfort. It's not just about the quantity of light, it's about the quality. First up, let's talk about uniformity. This is all about getting rid of those weird, patchy spots, where you have bright pools of light surrounded by kind of gloomy, dark areas. When you have high uniformity, the light is spread evenly. And that's so important because it stops your eyes from having to constantly readjust, which seriously cuts down on fatigue and eye strain. Next, we have to tackle the #1 enemy of comfort: glare. Now, Unified Glare Rating, or UGR, is fascinating because it's not just a physical measurement, it's a psychological one. It literally puts a number on that feeling of discomfort you get when a light is just too bright or it's right in your line of sight. And with glare, it's simple. Lower numbers are always better. And this shows you just how much the task completely changes the rules. For a hallway where you're just passing through, a glare rating up to 28 is totally fine. But for focused office work, that number has to drop below 19. And for something super intense, like technical drawing, the limit is an incredibly strict 16. Anything higher than that, and your concentration is just shot.
All right, so we've covered brightness and we've covered glare. But there's another huge piece of this puzzle: the color of the light itself. It plays a massive role, affecting both the whole vibe of a room and our ability to see details the right way.
So how do we describe that? Well, it's called correlated color temperature, or CCT. It's basically the mood of the light. Is it warm and cozy like a candle, or is it cool and almost sterile like a hospital lab? That feeling, that's what we measure in a unit called Kelvin.
And this is exactly why getting the CCT right is so critical. You have warm light, that's anything below 3,300 Kelvin, which creates that relaxing, inviting atmosphere you want in a home or a restaurant. Then you have cool light, over 5,300 Kelvin, which actually promotes alertness. That makes it perfect for places like hospitals or factories where focus is everything.
Okay, but what about seeing colors for what they really are? That's where something called the Color Rendering Index, or CRI, comes in. You can think of it as the truthfulness of the light. A light source with a high CRI, something close to 100, shows you the true colors of an object, almost like you were seeing it in perfect, natural sunlight. And this is critical for everything from design to safety. And believe me, this is where the stakes can get really high. For most normal rooms, a CRI of 80 is perfectly fine. But imagine you're a doctor assessing a patient's skin tone, or an electrician trying to tell tiny colored wires apart. In those situations, you absolutely need a CRI of 90 or higher. It's not just about aesthetics, it's a non-negotiable safety requirement.
Now, it would be great if we could just design for perfect performance and comfort all the time, wouldn't it? But we live in the real world, and that means we have to deal with two huge constraints: energy and time.
The first constraint is the energy budget. It's called lighting power density, or LPD. This is the absolute maximum amount of electrical power the lighting system is allowed to use per square meter. It's a hard limit set by energy codes and green building standards. There's no getting around it.
And just to put that into perspective for you, a modern office space usually has to stay under 9 watts per square meter. That is not a lot of power to work with, especially when you're trying to hit those high illuminance levels we were just talking about.
The second big constraint is time itself. See, lights get old, they get dirty, the room itself gets dusty. A designer can't just plan for how things look on day one. They have to use something called a maintenance factor. This is basically a multiplier that forces them to over-design the system just a little bit so that it still meets the minimum requirements years and years down the line.
And this isn't just some number they pull out of thin air. No way. A proper maintenance factor is calculated by looking at 4 different things: how much the lamp's output will fade, the likelihood of a whole fixture failing, how dirty the light fixture itself will get, and even how much dirt will build up on the walls and ceiling. It's a serious piece of engineering just to plan for the future. So when you put all of this together, illuminance, comfort, color, energy, and maintenance, you finally arrive at the designer's dilemma. This is the heart of it all. This is where the real art of the trade-off happens.
Here's a classic conflict. To get that nice, even uniformity, a designer might use lights that spread their beams out really wide. But here's the problem. The wider that beam, the more likely it is to shine directly into someone's eyes and create terrible glare. The solution is some really clever engineering. Smart fixtures with special micro-prismatic diffusers or louvers that can actually shape the light, giving you that great uniformity without all the discomfort.
And here's the other big one: power versus performance. You need 500 lux on the desk, but you have that super strict energy budget of less than 9 watts per square meter. How do you do it? The only answer is pure efficiency. This is where modern, high-efficacy LED luminaires are a total game-changer, squeezing out over 120 lumens of light for every single watt of power they consume. It's how you win that fight.
So the next time you walk into a beautifully lit space, just take a moment. You're not just seeing light. You're seeing a whole series of complex decisions, a balancing act between physics, psychology, performance, and power. The question is, will you just see the light, or will you now see the design behind it?